Hi, this is Srikanth, Assistant Professor of EEE Department. In this session, I'm going to cover the definitions on transistor amplifiers in the part of the subject elements of electrical and electronics engineering. So first, let us go with what is an amplifier. An amplifier is an electronic device that increases the voltage, current or power of a signal. Here, amplifier is a circuit which increases the input signal. Either it means of current, voltage or power. So in all the ways we are going to get the increased signal from the amplifier. Where amplifiers are used in wireless communications and broadcasting and in audio equipment of all kinds. These amplifiers, because in the communication system we require a signal should be amplified and that should be transferred. So that's why in the communication, in the wireless communication, we are going to use these amplifiers, and also for broadcasting we are going to use these amplifiers, and in all audio amplifiers, because whenever we are going with audio, that is whenever we are going to use the mic, okay, the mic has to receive a small signal and that small signal should be converted into a loud signal, that is into a large signal. That is going to be done with this amplifier. So all the mic sets and all the speakers are wherever we are going to use, those will be having the amplifiers. Those amplifiers are going to increase the sound signal from low level to high level. What is voltage gain? Voltage gain is nothing but what is the amount of gain is happened in the amplifier. That is nothing but what is the amplifier function? Amplifier is increasing the signal value from low value to high value. So the output value will be high and input value will be low. So the voltage gain is nothing but it is the ratio of output voltage to the input voltage. That is voltage gain. Gain is represented with A. Voltage gain is equals to V output divided by V input. Here that is nothing but if we take V output is across the collector voltage divided by input voltage is base voltage. Then like this we are going to have different values for different configurations of amplifiers. What is bypass capacitor? Actually, capacitor is equals to I. Capacitor current voltage relationships are I is equals to C dV by dt. That means capacitor does not allow sudden changes in the voltage. Capacitor does not allow sudden changes in the voltage. A bypass capacitor is a capacitor that short circuit the AC signals to ground. Short circuit the AC signals to ground so that any AC noise that may be present in the DC signal is removed. So a bypass capacitor is a capacitor which will make the short circuit for an AC signal so that any AC noise that may be present in the DC is removed, producing much cleaner and pure DC signal, which will produce the much cleaner and pure DC signal. Define current gain in BJT. Current gain in BJT is nothing but, here gain is nothing but, what is the increment? Amplifier is nothing but, it is a circuit which increases the signal from input. So whatever the input we give, it has to increase the signal either in the form of voltage, current or power. So when we take the current gain is nothing but, current gain of amplifier is defined as the ratio of output current to the input current. Here current gain IAI is equals to output current by input current. Output current divided by input current. Here what is the output current? Collector current. Collector current divided by base current. So here, which is equals to AI is equals to collector current is IC by IB. This is the current gain in the BJT. Define common base amplifier. The name itself says that common base. We are making base as common to the collector and the emitter. Base is made common to the collector and emitter. That is, we are going to give the collector to base voltage and emitter to base voltage. These are the two voltages which we are going to give for the amplifier. A single transistor BJT amplifier in which the input signal is applied to the emitter terminal and the output is taken from the collector terminal, and the base terminal is connected to a constant voltage, that is at a common point. And in the amplifiers, we need to keep the base junction should be forward bias and collector junction should be reverse bias. Define common collector amplifier. Here collector is made common. Collector is made common between base and emitter. So a single transistor BJT amplifier in which the input signal is applied to the base terminal, the output is taken from the emitter terminal. Here this is base is going to give the input and emitter is going to take the output, and the collector terminal is connected to a constant voltage, that is it is common between both base and emitter. Define common emitter amplifier. Here the name itself says emitter is made common between base and collector. So a single transistor BJT amplifier in which the input signal is applied to the base terminal, the output is taken from the collector terminal. Input is given to the base and the output is taken from the collector terminal, and the emitter terminal is connected to a constant voltage, that is made as a common between the base and collector. What is thermal runaway? Here thermal runaway is nothing but the transistor is going to lose its characteristics, that is self destruction of an unstabilized transistor is known as thermal runaway. Whenever the temperature levels in the junctions are increases, the self destruction of a transistor is going to happen, and that self destruction will make the transistor as unstabilized transistor, and that is known as thermal runaway. Define forward current gain HFB. Here HFB is nothing but it is a common base configuration, which is for all the H parameters. H is the H parameter symbol, F is the forward, and B is the what is the configuration which we are using. So the forward current gain for the common base configuration is defined as the change in collector current divided by the change in emitter current when the base to collector voltage is constant. Here HFB is defined as change in collector current delta IC by delta IE with VBC as constant. This is current gain in common base configuration. Define input impedance HIB. HIB. Here I is input, B is the common base. Here input impedance is nothing but it is the ratio of voltage phasor to the current phasor. So input impedance is nothing but it is the ratio of input voltage to the input current with output shortened, with output as short circuited. In the common base configuration, it is the ratio of emitter base voltage to the emitter current. That is, here we are taking the common as a base. So VEB, it is the ratio of VEB to the IE. This is called input impedance HIB. And define the reverse voltage gain HRB. HRB is nothing but R is the reverse and B is nothing but common base. It is the ratio of input voltage to the output voltage. Reverse voltage gain is nothing but it is the ratio of actually voltage gain is nothing but ratio of output voltage by ratio of output voltage to the input voltage. But when we are calling it as reverse voltage gain, it is the ratio of input voltage to the output voltage with our input short circuited. With input side is short circuited. In common base configuration, it is the ratio of emitter base voltage to collector base voltage. In common base configuration, it is the ratio of emitter base voltage to the collector base voltage with emitter current is 0, that is HRB is equals to emitter base, that is VEB divided by IE. Define output impedance HOB. HOB, here it is the ratio of output current to the output voltage with input open. In common base configuration, it is the ratio of collector current to the collector base voltage with base current 0. Here output impedance HOB is equals to V collector VCB by IC. Define forward current gain HFC. In the forward current gain for the common collector configuration, it is defined as the change in emitter current divided by the change in base current when the emitter to collector voltage is constant. Here forward current gain in HFC, that is HFC is nothing but collector, common collector. F is nothing but forward. So here the change in base current delta IB by change in emitter current delta IE by delta IB. Change in emitter current divided by change in base current when VEC value is constant. VEC value is constant. Define input impedance HIC. HIC is nothing but HI input and C is the common collector. HIC. Input impedance is nothing but it is the ratio of input voltage to the input current with output shorted. In the common collector configuration, it is the ratio of base to collector voltage to base current. In the common collector configuration, here it is VBC divided by IB, where the output is shortened. Next one, define reverse voltage gain HRC. HRC is equals to, it is the ratio of input voltage to the output voltage with input open circuited. Reverse voltage gain is nothing but it is the ratio of input voltage to the output voltage with input open circuited. In common collector configuration, it is the ratio of base to collector voltage to emitter collector voltage with base current 0. That is VBC by VEC at IB value is 0. So this is the reverse voltage gain. Define output impedance. Here it is the ratio of output current to the output voltage with input open. Here the output voltage is emitter to collector voltage and output current is emitter current. So HOC is equals to VEC by IE with IB value is 0. Now the next one is why CE configuration is most popular in amplifier circuit. The common emitter amplifier, why it is popular is the input is a base, because we know that the transistor is a current controlled device. So base current is going to be controlling the parameters in the transistor or conduction in the transistor. So base is the input which we are considering in the common emitter configuration, and we are collecting the output as a collector. So because of that, the current, voltage and power gains are quite high, and the ratio of output impedance and input impedance are quite moderate. So because of all these reasons, the CE configuration is more popular in amplifier circuits. The next one is define small signal amplifiers. When the input signal is so weak so as to produce small fluctuations in the collector current compared to its quiescent value, the amplifier is known as small signal amplifier. Here, because we are giving a small input signal, that is input signal is very weak, which has to produce small fluctuations in the collector current compared to its quiescent value. That is because of small signal, it has to produce some fluctuations in the collector current compared to the quiescent value. The amplifier is known as small signal amplifier. Define power amplifier. Here, when the name itself says power amplifier, what is amplifier? Amplifier will increases the signal from one level to another level. So the amplifier circuit that increases the power level of the input signal, and it is called power amplifier. Define voltage amplifiers. The name itself says voltage amplifier. Voltage in the input side is going to be amplified, or which is going to be increased, and that voltage will be available across the circuit. And the amplifier circuit that increases the voltage level of the input signal, and it is called as voltage amplifier. Define inverting amplifier. Here, inverting voltage amplifier is the circuit which produces an output signal which is an inversion of input like common emitter or common source amplifier. Here, inverting amplifier is the circuit which produces an output signal which is an inversion of the input, like common emitter or common source amplifier. Define H parameters. In electronics, especially in the field of linear circuit analysis, H parameters refer to hybrid parameters. These are the parameters are used to calculate the different relationships between the two-port network. So there will be different relations like voltage gain, current gain, input impedance, output impedance. All these parameters we are going to calculate with this H parameters. These parameters are used to describe the relationship between the input and output voltages and currents in a two-port network. Define distortion. The name itself says distortion. Distortion is nothing but it is going to distort the output waveform. So whenever there is distortion in the output waveform, so the signal is not clear. So that will create a losses in the load whatever we are connecting. So unwanted changes or addition to the original signal typically expressed as total harmonic distortion. Low distortion is desirable for high quality audio and other applications. For any applications, if let us take the example of audio, which is having certain distortions, like some different noises are going to get. Can we able to listen that unwanted noise? No. So we should have the high quality audio, and we can also require for all other applications also we require high quality output. Define slew rate. Slew rate is nothing but it is the maximum rate at which the output voltage of an amplifier can change. Which is what is the rate at which the output voltage of an amplifier can change. It is important in applications where rapid changes in the input signal need to be accurately reproduced, because whenever we go with some applications there will be rapid changes in the input signal that should be accurately reproduced with the amplifier. So the slew rate is nothing but it is the maximum rate at which the output voltage of an amplifier can change. Define dynamic range in amplifier. The range between the smallest and largest signals an amplifier can handle without significant distortion. Dynamic range is nothing but it is the range between the smallest and largest signals an amplifier can handle without significant distortion. It is often expressed in decibels and is crucial in applications where wide range of signal amplitudes are encountered. Define stability. Stability is nothing but it has to maintain the stable operations. The ability of an amplifier to maintain its performance and avoid oscillations under varying conditions, including changes in temperature, power supply, and load. Here, the ability of an amplifier is to maintain its performance and avoid the oscillations under varying conditions, which includes the changes in temperature, power supply, and load. Define input and output offset voltage. The name itself says input offset voltage. A small DC voltage that may be present at the input terminals even when no signal is applied. It can lead to a small DC offset in the output. If you give a small DC voltage, that will lead to a small DC offset in the output. Where output offset voltage, a small DC voltage that may be present at the output even with no input signal. It can affect the biasing of subsequent stages. The range of frequencies over, define bandwidth. Bandwidth is nothing but the name itself says width of a band. That is width of a band of frequencies. the range of frequencies over which the amplifier can effectively amplify a signal without significant loss or distortion. The bandwidth is often specified as the frequency range within which the gain remains within a certain tolerance. List the applications of common collector amplifier. Here the common collector amplifiers are used as voltage followers or impedance matching circuits, and they are suitable for applications where a high input impedance and low output impedance are required. Define voltage follower. A common collector amplifier is often referred to as emitter follower. In this mode, the output voltage follows the input voltage with unity gain. The gain is close to 1. So here in the common collector amplifier, the output voltage always follows the input voltage with a unity voltage gain that is nearly equals to 1. And in this session, we have completed all the definitions corresponding to the transistor amplifiers. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.